Beneath our feet, an entire world exists, hidden in the soil, tucked beneath fallen leaves, woven between blades of grass. Here, in the dim corridors of an underground fortress, tiny workers march in perfect unison. They carry burdens many times their own weight, guided not by sight, but by an invisible language of scent. In the blazing heat of a summer afternoon or the cool dampness after a rainstorm, their cities are alive with activity. To the casual observer, they're mere specks, almost invisible. But together, they form one of the most remarkable societies on Earth. These are ants, members of the family Formicidae, close relatives of bees and wasps. There are more than 14,000 known species, and scientists believe thousands more remain undiscovered. From tropical jungles to desert dunes, from city sidewalks to mountaintops, ants have conquered almost every environment except the frozen extremes of Antarctica and the highest peaks. What makes ants extraordinary is not their size, for they are small enough to fit on a fingernail, but their organization, cooperation, and resilience. Each ant is part of a superorganism, a colony where individuals sacrifice themselves for the survival of the whole. In many ways, they mirror the complexity of human societies, with farmers, builders, soldiers, nurses, and even undertakers, all working toward a common goal. Ants are among the most widely distributed creatures on the planet. They thrive in almost every terrestrial habitat. In lush tropical forests, tree-dwelling ants patrol the canopy, tending to sap-sucking insects that provide them with sweet honeydew. In arid deserts, species like the harvester ant forage in scorching heat that would kill many other creatures. In temperate woodlands, carpenter ants carve intricate tunnels through rotting logs. Even in bustling cities, pavement ants wage wars over tiny scraps of food. The adaptability of ants comes from their diversity. Some colonies may be small, with only a few dozen individuals, while others, like the infamous army ants of Central and South America, numbered in the hundreds of thousands, moving as a living, coordinated wave across the forest floor. The behavior of ants is deeply tied to their environment. In tropical climates, activity can be almost constant year-round, with colonies feeding, expanding, and defending their territory without pause. In temperate zones, the rhythm is different. As winter approaches and temperatures drop, many ants retreat deep underground, entering a state of dormancy until spring returns. In deserts, life revolves around extreme heat. Foraging may happen only in the cool hours of dawn and dusk, while the hottest part of the day is spent deep within insulated chambers below the surface. Rain can be both a blessing and a danger, bringing fresh growth and food sources, but also threatening to flood delicate underground tunnels. Ants also live in constant awareness of their neighbors. Competition is fierce, and territory disputes can lead to violent confrontations. Yet within their own colonies, cooperation is absolute. Ants do not survive as individuals. They survive as part of something greater. And so, in this bustling, invisible world, each ant moves with purpose, following trails only they can sense, driven by instincts refined over millions of years. But to understand the true genius of these creatures, their resilience, their ingenuity, and their role in shaping the land, we must first explore the world they call home.
The world of ants is as varied as the Earth itself. In the rainforests of the Amazon, the air is thick with humidity, sunlight filtering through a dense canopy. Here, leafcutter ants carve green highways through the undergrowth, each carrying a freshly cut fragment of leaf above their heads. Their underground cities can stretch for meters, with chambers the size of grapefruits and a population in the millions. Far away, in the African savanna, heat shimmers above the tall grass. Beneath the surface, harvester ants store seeds in carefully maintained granaries, protected from moisture and mold. Every tunnel is reinforced, every chamber strategically placed to catch a breeze or remain cool in the midday heat. In temperate forests, carpenter ants carve their nests inside fallen logs and decaying trees. Rainwater drips softly onto moss-covered ground, while foragers patrol the forest floor in search of insects, nectar, and sap. In winter, the forest falls silent, but deep underground, the colony huddles together, conserving energy until the snow melts. Even in deserts, where daytime temperatures can exceed 45 degrees Celsius, that's 113 degrees Fahrenheit, certain ants thrive. The Saharan silver ant, for example, emerges only for a few minutes at midday, when lizards, birds, and other predators retreat from the blistering heat. Its reflective, silvery hairs help deflect the sun's rays, giving it a survival advantage in an environment that seems almost impossible to endure. And then there are the urban landscapes. Beneath sidewalks, inside garden walls, and between cracks in brickwork, pavement ants build miniature fortresses. Here, their foraging trails wind through human spaces, crossing kitchen counters, scavenging crumbs from picnic tables, raiding pet food bowls. Wherever ants live, they are part of a broader web of life. In the rainforest, they interact with towering trees, fungi, and countless other insects. Leafcutter ants maintain a mutualistic relationship with a special fungus, which they feed with chewed leaves. In return, the fungus produces nutrient-rich structures that the ants eat. Without the ants, this fungus cannot survive. Without the fungus, the colony would starve. In savannas, ants share their environment with elephants, zebras, and birds, but their closest relationships are often with much smaller creatures. Certain plants, such as the acacia tree, offer nectar and shelter in exchange for protection. Ants patrol the tree's branches, attacking herbivores that try to eat its leaves. In deserts, ants compete with beetles and other insects for scarce food. They also become prey for lizards, birds, and spiders, forming a critical link in the food chain. Even in cities, ants interact with a surprising range of species: pigeons, rodents, cockroaches, and other urban dwellers. Some city plants benefit from ants' seed-dispersing habits, a service the ants provide unintentionally while carrying seeds back to their nests. Ants are often called the engineers of their ecosystems, and for good reason. By digging extensive tunnel systems, they aerate the soil, allowing air and water to reach plant roots more easily. In some habitats, ant nests improve nutrient circulation so effectively that plant growth is measurably greater around them. As foragers, ants help recycle organic matter. They remove dead insects, scattered seeds, and rotting food, preventing disease spread and returning nutrients to the soil. Certain ant species are also important seed dispersers, a process called myrmecochory. Seeds carried into their nests are often left uneaten in waste chambers, where they germinate in nutrient-rich conditions. Predator and prey, gardener and scavenger, ants wear many ecological hats. They control populations of other insects, sometimes acting as natural pest managers for farmers. They feed countless predators, from frogs to anteaters. In tropical forests, army ants even shape the behavior of other animals. Flocks of birds follow their columns to snatch fleeing insects, a feeding strategy known as ant following. Ants' ecological influence is so strong that removing them from an ecosystem can trigger cascading effects. Plants may fail to reproduce, soil quality can decline, and certain insect populations may surge unchecked. But life in these environments is not a constant march of progress. For ants, every habitat, no matter how rich or harsh, holds its own dangers. The soil may shelter them, but it can also betray them, collapsing in heavy rains or cracking in drought. Rivals lurk at the borders of their territory. Predators stalk their foraging trails, and the changing seasons can push a colony to the brink of starvation. Survival here is never simple. The land itself can be as much a predator as any living creature.
An ant's body is a masterpiece of efficiency, divided into three main sections: the head, the thorax, and the abdomen. The head holds powerful mandibles, jaws that can cut leaves, crush prey, or carry loads many times the ant's weight. These mandibles are shaped differently depending on the species. Slender and precise for weaver ants that sew leaves together, thick and crushing for soldier ants that defend their nest. Two long jointed antennae rise from the head like living sensors. Ants don't see the world as we do. Their compound eyes detect movement and light, but it is their antennae that paint the real picture. These organs detect vibrations, touch, and above all, chemical signals. Ants use pheromones to leave invisible trails, warn of danger, mark territory, and even identify members of their own colony. The thorax houses 6 spindly but powerful legs. Each foot ends in hooked claws for gripping rough surfaces, allowing ants to climb trees, walls, and even ceilings with ease. For some species, the thorax also powers small wings, used only by reproductive males and queens during their mating flights. Inside the abdomen, hidden from view, is a stinger in certain species, delivering venom that can paralyze prey or deter predators. Even without a stinger, many ants can spray formic acid, a potent chemical defense. Every adaptation, from armor-like exoskeleton to cooperative communication, is tuned for survival in a crowded, competitive world. A colony wakes with the warmth of the sun, though not all at once. Deep in the nest, workers stir, their antennae twitching. The foragers emerge first, fanning out along invisible highways. Some head toward a known food source, following a scent trail laid the day before. Others wander in arcs, searching for anything edible: seeds, nectar, dead insects. When food is found, the discoverer hurries home, reinforcing the trail with fresh pheromones. Soon more workers arrive, each one carrying a piece of the prize. The flow is constant, tiny bodies streaming in and out, each with a role to play. Inside the nest, nurses tend to the queen's brood, eggs, larvae, and pupae. The larvae are fed, cleaned, and rotated to ensure they grow in the most favorable conditions. The queen herself rarely leaves her chamber. Her primary duty is to lay eggs, sometimes thousands in a single day. Soldier ants patrol the entrances and major tunnels, ready to repel intruders. If the colony is attacked, they may sacrifice themselves to block passages with their own bodies. Meanwhile, waste workers haul refuse to designated dump chambers, far from the brood, to prevent disease. For some species, farming is part of the routine. Leafcutter ants meticulously cut and transport leaves, not to eat directly, but to cultivate their fungus gardens. The leaves are chewed into a pulp,
inoculated with fungal spores, and tended like crops. Other ants herd aphids, protecting them from predators in exchange for the sugary honeydew they produce. Life inside an ant colony is governed by a strict social hierarchy, but it is not enforced by dominance or aggression. It is built into the ants themselves. Every individual is born with a specific role shaped by pheromones, nutrition, and need. The queen, the colony's founder and primary egg layer. She can live for years, even decades in some species. Workers, the largest group, all female, they handle foraging, brood care, nest maintenance, and defense. Workers are often divided into subcastes, with smaller individuals tending to the brood and larger ones defending the nest. Soldier ants are oversized workers with massive jaws or specialized defenses. In some species, their heads are so large they can physically block nest entrances. Males, short-lived and built for one purpose, mating. They often die shortly after fulfilling it. Communication is the glue that binds this society. Ants don't speak, yet their chemical language allows them to coordinate complex tasks, from mass migrations to precision construction. Even in total darkness, they can find their way home, distinguish friend from foe, and adjust their behavior instantly to changes in the colony's needs. And yet, for all their physical tools and social genius, ants face constant trials. The year is never uniform. Rains come and go, the air cools and warms, and with each shift, the balance between survival and disaster changes. The most fascinating part of an ant's life is not just in its anatomy or daily rhythm, but in how it dances to the tune of the seasons. For ants, the turning of the seasons is not just a change in scenery, it is a shift in the rules of survival. In temperate climates, spring signals rebirth. The soil warms and dormant colonies stir. Workers dig fresh tunnels, repair damaged chambers, and forage for the first food of the year. Nectar flows from blooming flowers, and seeds scatter across the forest floor, a banquet for hungry foragers. Summer is the time of expansion. Colonies grow rapidly, food is abundant, and some species prepare for their mating flights. Winged males and virgin queens emerge on warm, windless days, taking to the air in vast swarms. This nuptial flight may last only a few hours, but it will decide the future of countless colonies. Most participants will never return, eaten by birds, trapped in spiderwebs, or falling to exhaustion, but a lucky few will mate and found new nests. Autumn brings preparation. As days shorten and temperatures drop, workers store seeds, plug entrances, and move deeper underground. The queen slows her egg laying, conserving resources for the long months ahead. Winter is a time of stillness. Deep in the nest, the colony enters diapause, a form of insect hibernation. Ants cluster together, sharing warmth in the darkness. Outside, frost locks the soil and food is scarce. Many colonies will not see spring again. In tropical climates, the rhythm is different. Instead of 4 seasons, there is the wet and dry cycle. The wet season brings bursts of plant growth and insect activity, while the dry season can mean long, lean months. Some tropical ants time their nuptial flights to the first rains, ensuring their new colonies have the resources to grow before the dry season returns. Ants may be fierce in their own world, but they are far from invincible. Danger comes from above, below, and even within their own ranks. Among their greatest predators are anteaters in South America, whose long tongues can sweep up thousands of ants in minutes. In the African savanna, aardvarks and pangolins perform a similar role, tearing open nests with powerful claws. Birds, lizards, frogs, and spiders also take a steady toll. Even rival ants are a constant threat. Colony wars are common, with thousands of casualties on both sides. Some species, like the Amazon ant, are slave makers, raiding neighboring colonies, stealing pupa, and raising them as their own workers. Parasites and pathogens are subtler, but just as deadly. Fungal infections, like the infamous Ophiocordyceps, can take over an ant's body, forcing it to climb to a high perch before killing it, allowing spores to rain down on unsuspecting victims below. Environmental hazards are equally dangerous. Heavy rains can flood tunnels, drowning entire colonies. In deserts, extreme heat can kill foragers within minutes if they misjudge the timing of their search. In forests, falling debris, shifting soil, or collapsing tunnels can entomb workers alive. To survive these challenges, ants have evolved an astonishing toolkit of behaviors. Flood management is critical for species in flood-prone areas. Fire ants in the southern United States can link their bodies together to form a living raft, floating for weeks until they reach dry land. The outer layer of ants trap air pockets for the ones inside, keeping the entire colony, queen and brood included, alive. Heat avoidance strategies are vital for desert species. Saharan silver ants wait until midday, when most predators retreat from the sun, then dash across the scorching sand. Their long legs keep their bodies elevated, reducing heat absorption, and their reflective hairs bounce away sunlight. They move fast, gathering food in mere minutes before retreating underground. Warfare and defense are constant in competitive environments. Army ants rely on sheer numbers and coordinated attacks, overwhelming prey or defending their territory with terrifying efficiency. In some forest species, soldier ants use their massive heads as living shields, blocking narrow tunnel entrances against intruders. Food storage is a hedge against scarcity. Harvester ants stockpile seeds in underground granaries, while honeypot ants store nectar in the swollen bodies of specialized workers called repletes, living food reserves that can sustain the colony during droughts. Symbiotic alliances can also help. Ants that partner with aphids or certain plants gain a steady food supply in exchange for protection. These alliances can make the difference between survival and starvation. For millions of years, ants have endured every trial the natural world could throw at them: flood and fire, predator and famine, heat and frost. Their strategies are as varied as their species, honed by evolution into near perfection. But in recent centuries, a new challenge has emerged, one that no amount of natural adaptation can fully prepare them for.
For most of human history, ants have been both allies and adversaries. Ancient farmers observed them carefully. Some valued ants for their ability to control pests, while others cursed them for raiding crops. In China, more than 1,700 years ago, citrus growers deliberately encouraged weaver ants to nest in their orchards, knowing the ants would patrol the trees and protect them from harmful insects. In folklore, ants often symbolize diligence and cooperation. Aesop's fables praise their hard work, contrasting their foresight with the recklessness of other creatures. Yet, in reality, our relationship with ants has always been more complicated. Some species have coexisted quietly alongside humans for centuries. Others have been seen as nuisances to be eradicated. The spread of agriculture and trade carried ants far beyond their native ranges. Ships unknowingly transported stowaway colonies across oceans. Some adapted seamlessly to new lands, becoming invasive pests that displaced local species and disrupted ecosystems. Today, ants face dangers more intense and widespread than ever before, and most of these come directly from human activity. Habitat loss is the most immediate. Expanding cities, farmland, and infrastructure carve up the landscapes ants depend on. Clearing tropical forests erases entire microhabitats, wiping out species that exist nowhere else. Even small-scale changes, paving over a meadow, draining a wetland, can fragment ant populations to the point where colonies fail. Pollution seeps into their world in ways we rarely see. Pesticides meant to kill crop pests can poison entire colonies, especially those that forage over wide areas. Plastic waste infiltrates soil ecosystems, altering microclimates within nests and leaching chemicals into the ground. Climate change brings slower but equally severe effects. Rising temperatures shift the range of many ant species. In cooler regions, some ants expand northward, while in hotter areas, colonies collapse under extreme heat. Changes in rainfall patterns disrupt the seasonal rhythms ants have relied on for millions of years.
Nuptial flights occur at the wrong time, food sources fail, and floods or droughts grow more frequent. Invasive species can devastate native ant communities. The red imported fire ant, accidentally introduced to many parts of the world, spreads aggressively, outcompeting local ants and threatening native wildlife. Their painful stings make them a public health concern, prompting widespread eradication efforts, which often harm other insects as collateral damage. Protecting ants is rarely as high profile as saving tigers, elephants, or whales. Yet ants are keystone species. Their disappearance can ripple through an ecosystem in unpredictable and damaging ways. Fortunately, scientists, conservationists, and even citizen volunteers are beginning to recognize their importance. Habitat preservation is the most powerful tool. Protecting large areas of natural forest, grassland, and desert keep entire ant communities intact. National parks and nature reserves often shelter dozens, even hundreds of ant species, many of which remain undescribed by science. Research and monitoring are essential. Long-term studies track changes in ant populations, providing early warnings of ecosystem decline. Because ants respond quickly to environmental shifts, they are excellent bioindicators, living signals of ecological health. Invasive species control is another focus. Biologists are developing targeted methods to slow the spread of harmful ants without destroying native species. This includes bait systems designed to affect only the target species, and restoring habitats so native ants can compete more effectively. Community engagement also plays a role. School programs and citizen science projects encourage people to observe local ants, collect data, and even help discover new species. In many countries, ant-themed exhibits in zoos and science centers are showing visitors just how intricate and important these insects are. In some regions, sustainable agriculture is integrating ants as natural pest controllers, reducing the need for chemical pesticides. The same principle used by Chinese farmers centuries ago, harnessing ant behavior for mutual benefit, is making a quiet comeback. To most people, ants are just tiny shapes scurrying along the ground. But look closer, and you'll see a superorganism, a living network of cooperation, adaptation, and resilience. Their cities are invisible to us, but they shape the soil beneath our feet. Their patrols are silent, but they guard the health of forests, grasslands, and even our crops. Every patch of earth they lose, every climate shift they endure, and every species we introduce changes the delicate balance they've maintained for millions of years. Protecting ants is rarely about saving one insect. It is about preserving the countless connections that keep our ecosystems alive. In the end, the fate of these creatures will depend not on their strength, but on ours. From rainforest canopy to desert floor, From frozen soil to city sidewalk, ants have conquered nearly every corner of the earth. We have seen their cities, hidden beneath our feet, intricate labyrinths of tunnels and chambers carved with precision. We have followed their trails, watched them farm, fight, build, and sacrifice. We have witnessed their adaptations, mandibles sharp as tools, antennae tuned to chemical whispers, legs carrying them over impossible terrain. We have seen them survive floods by becoming rafts, endure heat by racing across the sands, and store life itself inside the swollen bodies of living food reserves. In every environment, ants are not simply survivors, they are shapers. They till the soil, plant seeds, defend forests, and feed countless other creatures. Their societies have thrived for over 100 million years, long before humans, and, if given the chance, will continue long after us. And yet, for all their resilience, ants are vulnerable to the world we are remaking. Forests fall, climate shifts, invasive species spread. Each change ripples through their hidden networks. Sometimes the colony adapts. Sometimes it vanishes without a trace. Bend down and look closely at the ground. You might see a single ant carrying a crumb, a seed, or the body of another insect. Alone, it is fragile, almost insignificant. But remember, it is not alone. It is one part of a greater whole, a living system bound together by cooperation and purpose. Somewhere beneath your feet, in the darkness, the queen rests at the heart of her city. Around her, workers tend the brood, soldiers guard the gates, and foragers move in perfect rhythm with the world above. It is a silent miracle we pass over every day. We often imagine nature's wonders as something distant, lions on the savannah, whales in the deep. But some of the most extraordinary stories are playing out inches from where we stand. Ants do not ask for our help, yet their future may depend on whether we notice them at all. The wild does not always roar. Sometimes it marches quietly, in lines so small we barely see them. And if those lines should disappear, the silence they leave behind will be far greater than we ever imagined.